Stanišić from University of Novi Sad, Department of Architecture. Research topic is shaping the model of farming system facility, relying on the bioclimatic features of traditional Vojvodina houses to approach zero CO2 emission status. So the research problem, I think I forgot to do this. It's okay now. The research problem refers to the population, increasing the population of the villages in Vojvodina, and as a consequence, degradation of its traditional rural houses and their bioclimatic architecture. And on the other hand, the concept attempts to interpolate agricultural production into already overbuilt and polluted urban areas is making the villages even more neglected. So it is necessary to establish a unique strategy that would enable the revival of these rural communities, considering the application of its traditional bioclimatic building technologies in contemporary solutions, which would all allow us to see the old architecture in a new light in the conditions of the modern society. So the research objectives are to explore the possibilities of applying these passive design strategies in the contemporary architecture of a study project, farming system facility model, as a new model in the villages of Vojvodina. And also the aim is to increase their energy efficiency using renewable energy sources technologies in order to approach further approach to zero CO2 emission status of this model. Rural houses in Vojvodina in some way represent the identity of this area, and they are specific for their bioclimatic architecture, which is reflected in their accordance with the location and environmental conditions. So it is necessary to raise awareness of their benefits and, if it's possible, start from them in building new contemporary solutions. On the other hand, the abandonment of agriculture as also one of the consequences of the depopulation of the villages creates stagnation in economic and social growth. But since it has always been the main economic activity and the source of income in our country and this area, it is necessary to keep it within the rural boundaries whose environment will provide natural and sustainable farming conditions. So, as a strategy for the future development of rural areas in Vojvodina, this research presents a project study of farming system facility as a model concept for renovation of these abandoned and ruined houses by recovering and reusing its local bioclimatic architecture and by implementing modern renewable energy sources technologies in order to reach zero fossil energy homes. This strategy could establish rural-urban synergy in the villages and also preserve the agriculture within it, and in that kind providing employment and a new possibility of education for the rural population within a community-supported agriculture program, which is a program model for agriculture production, which allows every farmer, owner of the household in the rural area, to have his own members of his farm, and which he regularly supplies with agriculture products produced in his farm in the natural environment of the village. So this strategy could also urbanize the villages and approach them to the city lifestyle, and presents some kind of promotion of contemporary sustainable development in rural areas. Now we move on to shaping the model of farming system facility. So, yes. So now I move on to shaping the model of farming system facility study project as an architectural approach. So its architecture features are designed based on the analysis of the possibility to interpolate it within the existing structure and the environmental conditions of the villages in Vojvodina. So the starting point of this design of this facility was one of the previously defined existing typologies of Vojvodina houses, and that is a typology depending on the relationship between the house and the plot, from which these models were developed. So as a result, more possible variations of the farm system facility model are formed as a new typology in the villages of Vojvodina. Now I will present how the farm system facility typology was developed through the different aspects of the Vojvodina villages. First, we have environmental aspects, terrain configuration and climate. So the flat terrain and the continental climate with lots of sunny days per year and a relatively small altitude are the advantages of the Vojvodina's territory that contribute to the possibility of using solar and other renewable energy sources in the farming system facilities for the energy production needs. And also the physical geographic environment and the geological composition of the land most of all influence the choice of the construction material of these traditional houses, because the residents of these villages always use the material that they had close to the hand and in their immediate environment. So these construction materials are also used in the farm system facility buildings. Now we have village morphology. So this housing organization of traditional villages in Vojvodina are the result of the orthogonal urban scheme morphology from the time of the Teresian space planning, which we can see in this picture of village Novo Miloševo in Vojvodina. And this typical existing concept of this housing organization in the villages of Vojvodina with placing different content along the depth is very suitable for the exploitation of the solar energy. And the farming system facility models respect the basic and essential aspects of the Vojvodina housing organization. So there is its linear form, shape and dimensions of the plan, and also placing the side facade gable on the side regulation line, street regulation. Now we have plot landscaping. So this housing organization of the villages in Vojvodina enables favorable landscape information in order to reach better bioclimatic conditions. So in this case, vegetation has a double function as a temperature regulator, sun protection, and as a wind protection. As we can see in this picture, this of the typical housing organization in traditional Vojvodina village. So placing the deciduous trees in the south side of the plot is making the shadow and protection from the sun for the building in the summer, and also reduces the need for artificial cooling in this building because these trees absorb the sunlight rays, and that lowers the ambient temperature and reflection. And on the other hand, in winter, when leaves fall from these trees, they filtrate sunlight rays and allow them to get to the building. So this increases the heat gain of the building during winter months. Dominant winds in Vojvodina are Košava and Severac. Placing the coniferous trees on the north side of the plot is making adequate wind protection for the building throughout the whole year. And also deciduous trees on the south side can turn direction of dominant winds because in summer they are turn direction of dominant winds to the building, and in winter off it, as the deciduous trees have fallen leaves in the winter. So this landscape information is also applied in the housing organization of the farm system facilities. Now we move on to architecture. of the farm. So different types of farming system facility models are developed from this existing typology of Vojvodina houses. Typology depending on the relationship between the house and the plot. And these are the 5 types of that typology: farrow house, long house, front, corner, and turnkey house. So for each type of these houses, the farming system facility plan is developed, and each type of this farming system facility plan respects the basic characteristics of this existing typology, so its shape, dimensions, and a housing organization. Also, in case 2 neighbors want to join their farms and participate together in the community-supported agriculture program for agriculture production, they can the 2 neighboring plots can be connected, and then we have a bigger farm, and the farming system facility model plans would look like this. So this is typology of farming system facility on the joint plots. So this is the model design of the farming system facility on single plots for each type and joint plots. Farming system facility model has more floors than a typical Vojvodina house, but the story height is reduced, so the farming system facility would not disturb the panorama of the Vojvodina village. The application of the traditional gabled roof on these facilities enables the installation of the photovoltaic roof tiles that in this case are made in the same shape, color and dimensions as the traditional roof tiles, so the facility is in compliance with the environment in this case too. As we can see in these models, this farming system facility is a terrace design for the needs of the production area of the green roofs, which is not typical for traditional Vojvodina house, but the compliance with the environment is achieved with the installation of greenhouse that shapes the model in an archetypal form of the traditional Vojvodina houses. So from the pedestrian point of view, because the feeling of the terraces is lost, the building fully gets the appearance of the traditional Vojvodina house, but in the contemporary modern case. These houses in the Vojvodina villages can have different orientations because of the orthogonal scheme morphology, but the most favorable orientation is a 15 degrees angle east from the south. That allows the building to be more exposed to morning sun and have good daylighting and solar radiation gain throughout the year. So this orientation is applied in farming system facility models. Farming system facility household involves the farming, manufacturing, promotion and sale of agriculture products at the same time. And in addition, the education of young rural population is integrated inside the facility also, in order to give them the new possibility of education and employment in rural areas, so they wouldn't move to cities. So the agriculture is integrated in the farming system facility in that way that all 4 phases of agriculture product life cycle and farming system facility household make an inseparable union. And these 4 phases of agriculture production are organized in the 4 different sectors of the facility. So we have a farm field, a farm lab, farm restaurant, and farm market. Education is organized in all 4 sectors. These are the renewable sources from which the building meets its needs for the land use, energy use, water use, light, and the fresh air. This is the functional organization of the facility. So all 4 phases of the agricultural production are organized according to the levels of the facility. So the ground floor of the facility is divided into 3 sectors. The last part of the ground floor is for the residential rooms, for the owners. residential rooms, and part of the facility of the ground floor that is oriented towards the street. It's reserved for the farm restaurant, which is intended for the promotion of manufactured products, and is intended for the potential members of the farm, of the household. And this farm restaurant actually functions as an exhibition space. So in the ground floor we also have cube movable containers that serve as sales stands on the farm market, which is organized at the back of the plot at a certain part of the day. So the farm market is for the sale of the raw agriculture products, and the cube movable containers are pulled out from the building and they unfold at the back of the plot. So this is the illustration of the unfolded system of these cubes. The first floor of the facility is divided into two sectors. The enclosed spaces is a farm lab for manufacturing, packaging and the cold storage of the agriculture products. And the open terrace, the green roof, is for production of some kind of agricultural products besides the farmland, below the greenhouse. The second floor of the facility is also divided into a farm lab and a farm field. And education is organized in all four sectors. So the young rural population can learn all four phases of the agricultural production, and so they can apply their knowledge in their own household later on in the village. As an example of transformation and application of this farming system facility model, I will present just the traditional pharaoh house in the village of Vojka. This house was built from natural material, adobe, and this materials is also retained in the farm system facility model because of its sustainable characteristics. And also we can see in these illustrations of their plan transformation that dimensions and shape of the plan is retained, and also the typical three-part plan is retained. So this is the model transformation of this house, which is from the traditional pharaoh house type and is the same shape, size and height, and the landscape design is also maintained. And this is an illustration of all the applied strategies to approach zero CO2 emission status, both traditional bioclimatic and modern renewable energy sources technologies. And we can see in this picture that design, shape and appearance of the farming system facility models depend a lot of these applied strategies. And this is the pharaoh house on joint plots, actually. So there are conclusions. We can say that abandonment of rural areas represent a current problem for the entire world. And this farming system facility study project is an opportunity to prevent further departure of the people from the rural areas and attempt to improve the situation in the villages, but not only in the villages of Vojvodina, but also in some other rural areas where this model can be applied. And this can be achieved with the cherishing rural tradition and reusing its bioclimatic architecture. And also by applying these modern renewable energy sources technologies, which can provide for these facilities to be completely energy independent and the opportunity to reach zero CO2 emission status, which is a determined project goal of this study, which is planned actually in the following future research. So thanks for your attention.